Model serving is a challenging subject for many machine learning teams. In an ideal scenario, the same team that develops a model is also responsible for its deployment. However, it's not always feasible due to knowledge gaps or organizational structure. In that scenario, once the model is ready, it is handed over to another team for deployment. This creates a lot of overhead when it comes to debugging and communication. Databricks model serving and feature serving simplify the deployment process a lot, allowing data scientists to own the whole process end-to-end without relying on other teams. In this lecture, I will be walking you through different model serving architectures and when to use them. This is lecture 5 out of 10 of our free MLOps with Databricks course. And I will be talking about model serving architectures. In general, there are two main model serving architecture patterns. The first one is batch serving. Batch serving means that all predictions are pre-computed and stored in a database, and machine learning endpoint simply reads the prediction from the database on request, and there is no computation going on the machine learning endpoint side. Typical use cases can be personalization or recommender systems when you compute these recommendations in a batch fashion once per week, and then when the customer logs in, he will get these recommendations from the database. A second scenario is real-time model serving. It means that the machine learning endpoint is computing predictions at the request. It also can be so that it reads some of the features from the database and some features are available from the payload. Typical use cases can be fraud detection, also recommender systems, but also use cases like dynamic pricing. Let's now talk about these architectures on Databricks, how they can be implemented there. Let's take a look at feature serving first. In the most simple scenario, you have a Lakeflow job that roughly consists of 3 steps, which is data pre-processing, model retraining, and generation of predictions. It can also be 2 jobs instead, that you retrain your model once per week, but you generate predictions daily. In the end, after predictions are generated, we write them to a feature table. This feature table cannot be used directly behind a model serving or feature serving endpoint. We need to have an online store. It can be Databricks online store, which is using Lakebase on the background, or it can be an external online store like DynamoDB, which also integrates with Databricks if you use AWS. In the end, we need a feature spec, which is treated like a model by Databricks. And this is what is being served behind a feature serving endpoint. Feature spec is a combination of feature lookups and feature functions which define how we return features back. We can look them up in an online store, but we also can do some basic calculations using Python or SQL. And in the end, an application is sending requests to this feature serving endpoint and getting response back. Let's take a look now at the second scenario, model serving, which is also a very simple scenario similar to feature serving. That's what we are going to serve in this course. We are going to serve the custom model that we registered earlier. In the case of model serving, we have a Lakeflow job that does data pre-processing and model retraining, and in the end, we register model in Unity catalog. After the model is registered, it can be directly used behind a model serving endpoint because we are not looking up any features and all the features are available through the payload. So the app can send the request to model serving endpoint and get a response back without looking up anything anywhere. Model serving with feature lookup is the most complex but most realistic scenario when we have 2 different Lakeflow jobs. One is to do data pre-processing. In the end, we update the feature table in Unity catalog, which is used by another job to do model retraining. The schedule for these 2 jobs can be different depending on how often the features must be processed and how often the model must be retrained. The feature table is used to create a training set to retrain the model, and then we can also log the model and register the Unity catalog. However, in this scenario, model logging is using feature engineering package on Databricks. The feature table that was updated using the data pre-processing job also must be synchronized with the online store, similar to the scenario of feature serving, which we covered earlier. And the model serving endpoint needs to have a registered model behind, but also at every request, it needs to look up features in the online store. You don't have to set anything up, it's all done by Databricks using the feature engineering package. It creates a PyFunc that we can't really control, and in the end, model serving endpoint can be queried by the app and will return response back. So far, we walked through these 3 different architectures, but when should you use one or another? If you have a model artifact and need predictions to be computed at the moment of request, you need to use model serving. If you have a model artifact but not all the features are available through the payload and need to be looked up in the online store, you need to use model serving with feature lookup. If all the predictions are pre-computed, you just need to serve them, you need to use feature serving. If you need to compute a simple function that doesn't require model artifact, you could also use feature serving, just using feature function behind it. Thank you for watching this video. We walked through different model serving architectures and discussed how those can be implemented on Databricks. We also walked through a checklist when you should use different model serving architectures. In the next lecture, Bashak will take over and will show you how to deploy a model serving endpoint on Databricks. Stay tuned.